Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at bearings. So bearings are an application of trigonometry. Now, why are bearings needed? So here's the thing. If you told a pilot to fly to Sydney, they would know that they have to go in a northeast direction. But how would they ensure they don't end up in Brisbane? Brisbane is also northeast of Canberra. So what we need for things like that, for things like navigation, is we need a system where it's 100% clear in which direction you're going. So rather than just telling our pilot to start here in Canberra and go northeast, what we do is we give them an angle, give them one number, and they will know where to go. So that one number is the angle made with the north axis in a clockwise direction. So if you say to someone, go 0 degree bearing, they will go due north. 90 degrees is due east, and so on. So Sydney might be over in this direction. It might be an angle there of like 30 degrees. But that would not be the bearing we give. The bearing we give is always the angle made with the north axis in a clockwise direction. So to go there, we would actually say the bearing of 60 degrees. So this line here has a bearing of 60 degrees. Of course, if you wanted to go in this direction, let's say that angle there was 10 degrees. We wouldn't tell you to go 10 degrees because that would be up north. This bearing is the angle made with the north axis going in a clockwise direction. It'd be 180 minus 10. This would be a bearing of 170 degrees. If you told someone to go on a bearing of 235 degrees, they'd go down here. This angle here would be 235 minus 180. It would be 55 degrees. So if we give people a bearing, just one number, there is no ambiguity as to the direction they're going. If you say to someone go on a bearing of 235, they know that they're going southwest down here. They're not going southwest over here or whatever. All right, let's now look at using trigonometry to solve some problems in bearings. So I drive for 400 kilometers on a bearing of 160. How far south am I from my original starting position? So if you are not given a diagram in trigonometry, always draw one. So start by drawing a little compass. So we're starting here where the compass meets, and we're going on a bearing of 160. Well, 180 is due south, so it's going to be just over here. So let's draw that. We go down here, and this angle in here is going to be 20 degrees, 180 minus 160. Now, you know that trigonometry involves right-angled triangles, so let's draw a right-angled triangle. So this distance here is 400. We are being asked to find this distance here. This is how far south we went. So drawing the diagram is the hard part of this because now it's really easy to solve. We have a side that we need to find, but we have another side and an angle. We can easily use trigonometry. So of course, x is adjacent to the 20 degree angle and 400 is the hypotenuse. Adjacent, hypotenuse, we use cos. So cos of angle equals adjacent over hypotenuse. Because x, the thing we want to find, is on top, we times. So all we have to do is put in our calculator 400 times cos 20. So making sure that your calculator is in degrees, you get about 376 kilometers, and we're done. All right, let's now look at a question in which we have to find the bearing. So I drive 140 kilometers west, 200 kilometers south. On what bearing must I travel to return to my starting point? Once again, in trigonometry, if you are not given a diagram, draw one. So what we're going to do is draw our little compass. So this is our starting point. And then what's happened is we've gone 140 kilometers west and then 200 kilometers south. So we've ended up at this point here. So the question is asking us, if I want to go from here to where I started, what would be the bearing? Well, I've got to find that angle in there. So that's easily found. We have opposite and adjacent. So we're going to use tan. So theta is going to be tan. Now, because we're finding an angle, we use tan inverse, or shift and then tan on your calculator. So theta is tan inverse of opposite over adjacent. So we can put that straight in our calculator, making sure our calculator's in degrees mode. So putting that in the calculator, we get about 35 degrees. So that actually turns out to be the bearing because we're here and we want to go in a northeast direction. So it would just be 35 degrees. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.